This video covers the examples from section 5.4, product to sum, and sum to product formulas. Example 1. Write the product as a sum or difference. Part A, cosine of 6x times the sine of 2x. All right, let's back up to the previous slide. We had a situation of the cosine times the sine. That is going to be this identity or this formula right here, the cosine times the sine. We are supposed to take half of the sine of the sum of the angles minus the sine of the difference of the angles. So half of the sine of the sum minus the sum of the difference. Okay. All right, so for part A, we're going to take half of the sine of the sum of the angles, and the angles are 6x and 2x, minus the sine of the difference of the angles, so this will be 6x minus 2x. This will give us half of the sine of 8x minus the sine of 4x, and then we can write this as 1/2 the sine of 8x minus 1/2 the sine of 4x. And that's really all that we can do of that. The 1/2 would have to go on any coefficient out here in front of the sine. We can't take half of the angle because order of operations says we need to do the sine of it first before we multiply it by 1/2. So this is going to be our final answer right here. All right, let's look at part B. The cosine of 4x times the cosine of 5x. Let's back up to the previous slide. We had a cosine times a cosine. That's going to be this formula right here. We're supposed to do half of the cosine of the difference of the angles plus the cosine of the sum of the angles. So we're going to do half of the cosine of the difference plus the cosine of the sum. So for part B, we're going to do half of the cosine of the difference of the angles. So this is going to be 4x minus 5x plus the cosine of the sum of those angles. This is going to be 4x plus 5x. That's going to give us half of the cosine of negative x, or negative 1x, plus the cosine of 9x. And then we can distribute that half in there. That's going to give us half of the cosine of negative x plus half of the cosine of 9x. And then one more thing we want to do is we don't want to have this negative inside of here. We'd like to bring it out. Well, remember, the cosine is an even function, and that means that the cosine of negative x is the same thing as the cosine of x. So I can simplify this further and write this as 1/2 of the cosine of x plus half of the cosine of 9x. And this will be my final answer right here. Example 2, use a product to sum formula to find the exact value of the sine of 165 times the cosine of 75. All right, so we have a sine times a cosine. Let's back up here. The sine times the cosine, that's this formula right here. And we're going to take half of the sine of the sum of the angles plus the sine of the difference of the angles. So half of the sine of the sum plus the sine of the difference. All right. And we're going to have half of the sine of the sum of our angles. So this is 165 plus 75 plus the sine of the difference of those angles. So that'll be 165 minus 75. We can simplify this because we can actually add those angles together. So we have 1/2 of the sine of 240, 165 plus 75, plus the sine of 90. That's 165 minus 75. And we can actually simplify this further because from the unit circle, I know what the sine of 240 degrees is. That's over in quadrant 3, and it corresponds to, that corresponds to 4 pi over 3, and the sine at 4 pi over 3 is going to be a negative square root of 3 over 2. And then the sine of 90 degrees is going to be positive 1. Now this just becomes a regular arithmetic problem. So we're going to have half of negative square root of 3 over 2 plus 2 over 2. This is so I can get a common denominator, which is going to give me half of negative square root of 3 over 2 plus 2, and then all that's over 2. And then to multiply fractions, we just multiply the top times the top and the bottom times the bottom. So this is going to give me negative square root of 3 plus 2 over 4. And that is going to be my final answer right there. Example 3, write each expression as a product. Part A, cosine 5x plus cosine 2x. All right, let's back up. We have a cosine plus a cosine. That's going to be this formula right here where we have a cosine plus a cosine. We're going to turn it into this over here. We're going to have 2 times the cosine of the sum over 2 times the cosine of the difference over 2. So 2 times the cosine of the sum times the cosine of the difference. Right, now let's apply that. 2 times the cosine of the sum over 2 plus the cosine, I'm sorry, that was supposed to be times. Try that again. Times the cosine of the difference. This is going to give me 2 times the cosine of 7 over 2x times the cosine of 3 over 2x. And I did an addition there that I shouldn't have done. This should be a subtraction. Yeah, subtraction, the difference of the angles. Let's try that again. Okay, so now we have that fixed as the difference of the angles divided by 2. 5 minus 2 is going to give me 3, so we have 3 halves x. Again, we don't want to multiply that 2 by the angle because the order of operations says we have to cosine it first before we can multiply it by 2. That means this is going to be my final answer right here. Okay, part B. We have the sine of beta minus the sine of 5 beta. All right, let's back up. We have the sine minus the sine. The sine minus the sine, that's going to be this one down here. We've got 2 times the cosine of the sum times the sine of the difference. Okay, 2 times the cosine of the sum times the sine of the difference. Let's apply that. We have 2 times the cosine of the sum times the sine of their difference. All right, let's simplify this a little bit. We're going to have 2 times the cosine of 6 beta over 2, but that's going to reduce to 3 beta. And then we're going to have the sine of negative 4 beta over 2, and that's going to reduce to the sine of negative 2 beta. Now remember I said I don't want to have this negative as part of the angle, so I'm going to need to simplify this just a little bit. The sine is actually an odd function, and that means when I take the sine of a negative angle, it's the same thing as if I take the sine of that positive angle and then multiply that by negative 1. So I'm going to take that negative right there and I'm going to bring it out in the front over here. That's going to give me negative 2 times the cosine of 3 beta times the sine of 2 beta. And that is going to be my final answer right there. Example 4. Use a sum to product formula to find the exact value of sine 75 degrees minus the sine of 15 degrees. All right, let's go back. We have the sine minus the sine. That's going to be this formula right here that we just used. So we'll have 2 times the cosine of the sum times the sine of the difference. We have 2 times the cosine of the sum, 75 plus 15 over 2, times the sine of the difference, 75 minus 15 over 2. This is going to give me 2 times the cosine. Let's see, 75 plus 15, that's 90 over 2, times the sine. Let's see, 75 minus 15, that's going to give me 60 over 2. We can actually reduce these angles now, so we have 2 times the cosine of 45 times the sine of 30, and now using my unit circle I can simplify this further into 2 times, let's see, the cosine of 45 degrees, that's square root of 2 over 2, and then the sine of 30 degrees, that is 1/2. And so it looks like we're going to have 2 times the square root of 2 over 4. That's 2 times the square root of 2 times 1 divided by 2 times 2. And this actually reduces this fraction right here on the outside. That becomes 1/2. So we reduce down to the square root of 2 over 2. And that right there is going to be my final answer. Example 5, verify the identity. The cosine of 4x minus the cosine of 2x divided by the sine of 2x minus the sine of 4x is equal to the tangent of 3x. Okay, I think I'm going to be working over here on the left because it's a whole lot easier to take a lot of stuff and collapse it down into one thing than it is to take one thing and expand it out into a bunch of things. And because I have a difference of cosines here, I think I'm going to use some of my formulas and see if I can simplify this a little bit. I want to take this difference and turn it into a product. And then I'm going to take this difference and turn it into a product. So let's look at this one first. The cosine minus the cosine. All right, that's going to be this one right here. This tells me to do negative 2 times the sine of the sum times the sine of the difference. Negative 2 times the sine of the sum times the sine of the difference. That's going to give me negative 2 times the sine of their sum over 2 times the sine of their difference. Okay. And then let's take a look at this bottom one here, the sine of 2x minus the sine of 4x. We'll go back to our formulas. The sine minus the sine, that's this one down here on the bottom. We'll have 2 times the cosine of their sum times the sine of their difference. 2 cosine sum, sine difference. And 2 times the cosine of their sum, 2x plus 4x, times the sine of their difference, 2x minus 4x over 2. And we want this to be equal to the tangent of 3x. All right, let's simplify a little bit up here in the numerator. 4x plus 2x, that's going to give us 6x. Negative 2 sine 6x over 2 times the sine. 4x minus 2x is 2x, so we'll have 2x over 2 over 2 times the cosine. 2x plus 4x, that's 6x, so you have 6x over 2. And then over here, 2x minus 4x, that's going to be negative 2x over 2. And we want this to be equal to the tangent. Now, if you want to, right here at this step, and really back here at this one if you wanted to, you can go ahead and cancel out those 2's right there. You don't have to, you can wait till later, but you can cancel them. And I'm just going to go ahead and cancel them out right now. And we're going to simplify this. 6x divided by 2 is 3x. So I have negative sine of 3x times the sine. Now I have 2x over 2. That just simplifies into x. And on the bottom, we have the cosine. Again, 6x divided by 2 is going to be 3x times the sine. Negative 2 divided by 2 is just going to give me a negative x. And we want this to be equal to the tangent of 3x. All right, there's that negative again in there with the angle. So we have to remember that the sine is an odd function, and that means when we take the sine of a negative angle, it's the same thing as taking the sine of a positive angle and then multiplying that by a negative 1. So what that means for me is I'm going to take that negative and I'm going to bring it out in the front right here. And now we're going to have negative sine of 3x times the sine of x over the negative cosine of 3x times the sine of x. And we want this to be equal to the tangent of 3x. If we look at our fraction over here, I can actually cancel out the signs now. So let's do that. And I can also cancel out the negatives, because a negative divided by a negative is a positive. So let's do that. That leaves me with the sine of 3x over the cosine of 3x. And we want that to be equal to the tangent of 3x. Well, now I want to use my quotient identity because I know that the sine divided by the cosine is the tangent. And then the argument, which would be the angle right here in parentheses, is going to be 3x. And we wanted that to be equal to the tangent of 3x. And so we have just proven our identity.